In this video, we're going to walk through how to do the 5153 review worksheet. And so the first problem that we're dealing with is a multiple choice. What basic trig identity would you use to verify that tangent of x times cosine of x equals sine of x? Well, if I were to just focus on this, and I want to verify that the left-hand side equals the right-hand side, I'm going to need to create common terms. I have a sine, I have a cosine, but I don't like this tangent. And so what I would do in this problem is I would change my tangent of x into sine of x over cosine of x. And I'll do this on the right side. So tangent of x is sine of x over cosine of x. And I'm multiplying by cosine of x. And that equals the sine of x. And I would use that basic trig identity because that would allow me to cross out the cosines. So the problem is asking what identity would allow you to verify this. And between my choices A, B, C, and D, I used A. I took the tangent of x and I changed it into sine of x over cosine of x. And that allowed me to verify the identity. So that's what number one's asking. Number two then is asking us the same thing. What basic identity? So I'm going to look at this first. Well, I'm going to change the left-hand side in this case, and I notice right away sine squared plus cosine squared. I have two trig identities squared being combined together, so that makes me think it could be a Pythagorean identity. And if I were to take a look, sine squared of x plus cosine squared of x is 1. So on the left side, I have 1 on top, cosine on the bottom. And so the first identity I use to verify is that sine squared of x plus cosine squared of x equals 1. So it looks like A is the choice here. That's the one I used. Now I do know the next step, if I wanted to verify, is that cosine of x equals, on the bottom, equals secant of x. So a lot of students want to say the answer is D, but it's not. Because here are the cosines on the bottom. So the next step I would have done was secant of x equals secant of x. So as you go through, be aware, and that's kind of why I stopped talking about choice D briefly, was that this one visually makes people want to choose it, but it's not the one you use, because this is 1 over cosine, not 1 over secant. So do be careful on making sure you have the right identity in the right location. And that's why I kind of go step by step and see the first thing I did, and then I look at my choices and I see the answer is A. So that's 1 and 2. Let's look at number 3. Number 3, I am going to change the right-hand side. I'm going to leave this as cotangent of x. And so cosecant of x is 1 over sine of x. And then secant of x is 1 over cosine of x. And I'm going to stop for a minute to kind of explain why I changed the right-hand side. Is as I'm going through, I have to think about what do I want to create. And in this case, I want to create just cotangent. And so in my mind, if I want cotangent, there's only a very basic way of getting it as cosine over sine. And so something tells me that this is going to be the key that I need to create on the right side to give me the left side. So if I take a look, I'm dividing by a fraction. So if you watched the previous videos that we've done, is we notice this is another theme that pops up. Dividing by a fraction means that you flip the fraction at the bottom and you multiply. So I have 1 over sine of x times cosine of x over 1. And notice that gives you 1 times cosine of x is cosine of x. Sine of x times 1 is sine of x. And that is exactly what I said we would probably want to create. And so my last line is cotangent of x equals cotangent of x. We can box it. Q, E, D. We have demonstrated the left-hand side equals the right-hand side for it. So that one, pretty straightforward, but again, the theme with divided by a fraction popping up. Let's look at number 4. Now, number 4, a lot of people jump right into it and think they're confident that, oh, I just bring the squared in, and that's how I square the binomial. And remember, that doesn't work. you cannot distribute a squared across a plus or minus sign. Those are not the operations. What you have to do is you have to remember, what does it mean to square something? And that means to multiply it by itself. So I'm going to change the left-hand side. I'm going to write sine of x minus cosine of x and sine of x minus cosine of x in their own parentheses. And I'm going to keep the right-hand side. And so in this case, I'm going to distribute sine times sine. So sine of x times sine of x is sine squared of x. Sine of x times cosine of x is sine of x times cosine of x. In this case, it's negative. Negative cosine of x times sine of x is negative sine of x cosine of x. And then a negative times a negative is a positive, and I get cosine squared of x. So I distributed the left side, and I'm going to keep the right side as I go through. And I'm going to pause and take a look to see what happens. As you go through, do look. I see I have a sine of x cosine of x here. And I have it here too. Actually, I have two of them. And that's interesting because I want two of them. And I want them to be negative. Well, I do have two of them. They are negative. So that gives me, when I combine those, negative 2 sine of x cosine of x, which is exactly what I wanted on the right side. Problem is, what about the left side? Because I have a sine squared. I have a cosine squared. Well, a commutative property allows me to put these next to each other. And sine squared plus cosine squared, sine squared of x plus cosine squared of x is a Pythagorean identity. Which is exactly what I wanted. So 1 minus 2 sine of x equals 1 minus 2 sine x cosine x equals 1 minus 2 sine x cosine x. It has been demonstrated, QED. So this one, a lot of people want to jump right into trying to distribute the squared. Don't. Remember the definition. What does it mean to square something? And that is to multiply by itself. So be aware of that. Let's look at number 5. There are a couple of cool ways of doing number 5. My way that I would do right away is I would take a look at it, and I'm going to keep the right side, sine squared of x, and I'm going to change the left side. Now, right away to me, I'm trained myself. I can see that if I have a square trig function, a plus or minus, there's a chance I have a Pythagorean identity. It's not guaranteed, but it's a chance. So I look there first. And so if I look at secant squared of x minus 1, and I would look at the formulas for it, I believe that is tangent squared of x. And so I have cosine squared of x times tangent squared of x. How does that help me? Well, I can change tangent squared of x into sine squared of x over cosine squared of x. And let me just finish writing down the left side. It was, I'll write it like it's a fraction. It was cosine squared of x. If it makes you feel better, put it over 1. Go ahead. And the right-hand side stayed the same. And notice it's all multiplication. Again, a common theme. When it's all multiplying, you can cross out common factors in the top, common factors in the bottom. And I get sine squared of x equals sine squared of x. QED, done. Now that's one way. And that's, like I said, that's the way I see it. I see the Pythagorean identity first. So I go that route. But what's interesting is you can do another way. I could also distribute. And I'll keep the right-hand side again. But I could distribute cosine squared times secant squared. And the reason why is because these two are reciprocals of each other. And when you multiply a number by its reciprocal, you get 1. And so that's a really good move because it allows me to change and get rid of these two trig ratios right away. And then I'm going to do cosine squared times negative 1. So that's just negative cosine squared of x. Again, notice you have a square trig ratio and a number. I have subtraction, so that makes me think it's a Pythagorean identity. And it is. 1 minus cosine squared of x is sine squared of x. And look at that, it's actually one less step. than the other problem. Get there. I'll even write QED again. So it doesn't matter as long as your trigonometry skills are accurate mathematically, but it works both ways. So I don't care which one you use. Let's look at number 6. Now, number 6 is a little bit different. We're not verifying in number 6. We're asked to find secant of x if we're given tangent squared of x. So I'm going to want to solve for this. Well, I want to find which trig identity, which formula links secant to tangent. If we were to look at our formula sheet, we would see that secant squared of x equals 1 plus tangent squared of x. Well, notice you're given tangent squared of x equals 1/2. So let me erase this and kind of focus. I am told what tangent squared of x is. So I am going to replace the tangent squared of x with my 1/2. So I know secant squared of x equals 1 plus, now I don't need to square it because I'm already told what tangent squared is. It is 1/2. So I'm given secant squared of x. If I create common denominators, 1/2 plus 1 is 3/2. So notice I have my secant, which is awesome, but the problem is I want secant, and yet I have secant squared. So that doesn't work for me. But I do know I can square root both sides. And so I have secant of x equals the square root of 3, and I'm going to split the radical over the top and bottom. Well, we can't have a radical denominator, so we have to rationalize. So I'm going to multiply by a clever form of 1, radical 2 over radical 2. So that gives me secant of x, radical 3 times radical 2 is radical 6. And when I multiply these two together, I get just 2. And so there's my answer. If you want to kind of see where we learned this before, because it's been a while, it was some of the problems that we did on the front page of our 5.1 notes for it. I think it was the 3 problems that are on the bottom of the page. So you can take a look. It's asking us to find the formula that connects them together, plug in, and just kind of solve for it. Not really related to the previous problems on the page. Let's look at number 7. Now, number 7's interesting because it looks really complicated, especially with the denominators. But let's talk about themes that appear. Is when I am adding 2 fractions together, which I can see I'm doing on this left-hand side. The main thing that's repeated in 5.1 and 5.2 is you always need a common denominator between them. And the common denominator in this case, I'm going to put parentheses because these are actually factors. They're binomials. So my common denominator in this case is 1 minus cosine of x times 1 plus cosine of x. So let's create that. If I have the first one, and I have 1 minus cosine of x, the next fraction is a 1 on top and a 1 plus cosine of x. And I'm going to write the right-hand side 2 cosecant squared of x. All right. The left-hand side, this is missing a 1 plus cosine of x on the bottom. So I'm going to put it on the bottom, I'm going to put it on the top. It's missing a 1 minus cosine of x. I'm going to put it on the bottom. I'm going to put it on the top. Done. Again, you may think that it looks complicated, especially when you create a common denominator because you have all these parentheses and stuff, but it's going to simplify down for us. I mean, that's the point. When you're adding 2 fractions together, you want to create a common denominator so you can merge them into one. And the one you're going to merge them in is going to have that common denominator. So I'm just going to write this down. In the bottom, 1 minus cosine of x times 1 plus cosine of x. But what about the top? Now I'm going to take and do my time for this. I'm not going to try and skip steps. Is I would multiply everything by the 1, which doesn't change anything. And I would multiply everything by the 1, which doesn't change anything. So I have 1 plus cosine of x plus 1 minus cosine of x. Looks like I'm going to need to get some room. So when I'm doing this, I'm going to simplify the top. And so 1 plus 1 equals 2. So these two combined give me 2. Which we're going to stop for a minute and take a look. I want a 2. I mean, look at the right-hand side. You want a 2. You created that. So I'm not going to change that 2. I'm going to keep that 2. And let's see what else happens. Well, on the top, I have a positive cosine of x, and I have a negative cosine of x. Well, when I combine those together, they just cancel each other out. So really, all I have left on top is just that 2, which is interesting because, well, what else do I need? I have the 2, well, I want cosecant squared. Well, cosecant squared means you have a sine squared on the bottom of a fraction. But I don't have a sine squared on the bottom of the fraction. I have cosine, which means somehow I have to create this. So what I'm going to do is I am going to distribute the denominator. And do keep in mind, if you haven't noticed yet, is these two are conjugates of each other. They have the same terms, the opposite operation, which in a way is just your difference of squares factor. So I'm going to square my first term, which is a 1, and I'm going to square my second term, which is the cosine of x, and I'm going to subtract them. So I have 1 minus cosine squared of x. So why does that help? Well, now I have a 1 minus cosine squared, which makes me think it's a Pythagorean identity. And it is. 1 minus cosine squared of x is sine squared. So I still have that 2 on top. Notice I didn't touch it because I want it. And look at that. I created the sine squared in the bottom that I wanted, which is sine squared in the denominator is a cosecant squared. So I do get 2 cosecant squared of x equals cosecant squared of x. It has been demonstrated. So why this problem? It looks complicated, and I get that. But notice our theme. We are adding 2 fractions together, so we need to create a common denominator for it. That is really important concept to understand. You add 2 fractions, you need to merge them into 1 for it. We also have a Pythagorean identity as well, a square trig ratio with the number 1. There's a very good chance it's an identity. We had the idea of, sorry about that, we have an idea about conjugates there. And so there's a lot of concepts that you need to be confident with in this example. So overall, it contains a lot of information, and it's just little pieces here and there for it. And one of the big things I like about it is it allows you to go and look left to right in the middle of the steps and see you're on the right track for the problem. Let's look at number 8. Cosecant squared of x times tangent squared of x minus 1 equals tangent squared. So I'm going to keep right hand side, and we'll try and do this fast, is cosecant squared of x is 1 over sine squared of x. Tangent squared of x is sine squared of x over cosine squared of x. And I have the minus 1. I'm switching to common terms that will allow me to kind of merge these two together, and I notice multiplying so I can cross out any common factors in the top and bottom. So I'm left with 1 over cosine squared of x minus 1 equals tangent squared of x. Well, I notice cosine on the bottom means secant, so I have a secant squared of x minus 1 equals tangent squared of x. I have a squared trig ratio with a 1. It makes me believe there's a chance, not always given, there's a chance it's a Pythagorean identity, and it is. It's tangent squared of x. So tangent squared of x equals tangent squared of x. It has been demonstrated. Left-hand side equals the right-hand side. Done. So that's number 8. Number 9. Very, very interesting on number 9. It's a little unique for this one. This one is similar to some problems in the 5.2 worksheet. Notice what terms you have on the right side. Now I'm going to keep the right side. I have a sine squared of y. The problem is on the left side, I have a cosine squared, and I don't want cosine squareds. I only want sine squareds. So I like this. I mean, I want to keep that minus sine squared of y because I want a negative. I'll get the highlighter. I want a negative sine squared. Actually, I want 2 of them. I have only 1 so far. but I want to keep it. And I hope you can understand and look at the right side to help you see what to keep and what not to keep. I don't want to keep cosine squared, but that is actually a Pythagorean identity. I referred to this in the previous videos as a reverse Pythagorean identity. Cosine squared is 1 minus sine squared. And so I can go reverse for it, and what's nice is that does change it so it has a sine squared. I'm using and creating the same terms. So I have a 1, which by the way, I want a 1, right? And I have a negative sine squared and another negative sine squared of y. So really I have 2 of those, which is exactly what I want. So in this case, it's a Pythagorean identity, but it was done in reverse. And that's going to happen on occasions when you're trying to create the same trig terms. And I only have a sine squared here. There's only one way that cosine squared relates to sine squared. And that's by going backwards with the Pythagorean identity. And so now let's look at number 10. So number 10 may look a little interesting for it. I'm going to keep the right-hand side, but I'm going to be a little careful. I'm going to take a moment and talk about what not to do. You cannot cross out these secant squares of x's. And the reason why you can't cross those out by common factors in the top and bottom is because it is not all multiplication. There's a minus sign on the denominator and denominator, so you can't do that. So that's my warning, is a lot of students want to be tempted that if they see something that's the same on the top and the bottom, just to go right to canceling them out, which doesn't work because of that minus sign. So there's my disclaimer in the beginning. And I would not do that because the top isn't that bad right now. It's a secant squared of x. The denominator should bother you because there's 2 terms. However, it's a squared trig ratio and a 1. So just like before, is it a Pythagorean identity? And so if I look at this, secant squared of x minus 1, well, that's just tangent squared of x. So not bad. I no longer have a plus or minus on the bottom, which is good because then I can cross out common factors if I create them, which I believe is going to actually be the step we want to do, is we want to create common factors. So, well, how do I do that? If I take a look, I'm going to look on the right side because that's what I want. I want cosecant squared of x. Well, I know cosecant means you have a sign in the denominator. So cosecant squared means you have a sine squared in the denominator. So something tells me we're going to probably get to that point. So I'm keeping that in the back of my head. I'm probably going to end up somehow with the sine squared in the denominator. So how do I do that? Well, on the left side, I don't have sines and cosines. So I'm going to create those. So secant squared of x, I can change. I can write it as 1 over cosine squared of x. And tangent squared of x, I can change into sine squared of x over cosine squared of x. My right-hand side stays the same. That's really interesting because I want a sine squared, and I am actually creating a sine squared, which is great. So like I want this, and I can see it right here. So I know I'm on the right track, which gives me more confidence. If I start looking left to right and seeing what I want and what I'm given, it's going to give me more confidence that I know I'm on the right track for solving things. So let's see, if I go through, well, I'm dividing by fraction. There's that concept again. If we're dividing by fractions, we want to flip the denominator and multiply it. We want to multiply by the reciprocal. So I get cosine squared of x over sine squared of x. And just like I said in the previous step, notice your sine squared of x is in the denominator just like you wanted. And it's all multiplication, which now I can cross out common factors. So I have a 1 over sine squared of x equals cosecant squared of x. You always put that last piece in the puzzle. 1 over sine squared of x is cosecant of x. So cosecant squared of x equals cosecant squared of x, Q, E, D, done. And again, I want to point out right away, in the first step, I made the statement that I want to create a sine squared in the bottom. And look at this. In the last step before our QED, we did that. So when you're trying to figure out how to solve, see where you're going, see what the end game is, and kind of start reverse engineering. How do I create that? Okay, so that's my next step. And it might help you understand what to do. And what's really interesting when you analyze number 10 is you realize we didn't cross out here in the first step because there's the minus sign. But as soon as it became all multiplication, we were allowed to cross out common factors. So what's good about number 10 is it kind of distinguishes between that. It shows you when you can cross out common factors and when you can't. All right, number 11. If cosecant of x, find cosecant of x, if sine of x plus cotangent of x times cosine of x equals radical 3. So I want to find cosecant of x. So that tells me my last line needs to read cosecant of x equals something. So let's just focus on simplifying this left-hand side. So I notice I have a sine, I have a cosine, but then I have this cotangent. I don't like that. I want common terms. So I'm going to change cotangent of x into cosine of x over sine of x. And I'm going to leave that cosine of x. And again, if it makes you feel better, you can put it over 1 equals square root of 3. And let's see what happens. So I have sine of x still by itself. We haven't done anything with that yet. But over here, I have cosine times cosine, which is cosine squared, and sine of x times 1, which is sine of x. All right, so that's not bad. We're working through our problems. We can see where we're going. What I see right now is actually a theme that we've seen before is I have a number and I'm adding a fraction to it, which means I'm going to need to find a common denominator. So in this case, this is really over 1. I am going to need to multiply the first fraction by sine of x in the denominator, so I have to do it in the top. And so why does that help? Is now that I have a common denominator, I can merge them together. And I was going through and doing this just like it was a previous problem, like 5.2 stuff, just kind of working on one side. And I haven't talked too much about why am I still going this way. And I want to find, I believe, cosecant of x, which means I want a sign in the denominator. And notice, as I worked through, that's what I created. I created a sine of x in the denominator. Well, what's sine squared plus cosine squared? That's 1, based off of Pythagorean identity. So I get 1 over sine of x equals square root of 3, which 1 over sine of x is cosecant of x. So I do know what cosecant of x equals. It equals square root of 3. So there we are. That's number 11. Number 12. This is a sum and difference formula. 15 degrees is not in our trig chart. So I need to figure out how do I create 15 degrees. And I do that by taking, at least I would take 45 degrees and subtract 30 degrees. And so this is a difference formula for sines. And so for sines, I do sine, cosine, cosine, sine. And when you have the formula for the difference of signs, whatever the sign is in between them, for difference of signs, it stays the same. And I am just going to plug in 45 degrees, 30 degrees, 45 degrees, 30 degrees. And since those are angles that are on the unit circle, I can go through and find those values. The sine of 45 degrees is radical 2 over 2. The cosine of 30 degrees for us is radical 3 over 2. Minus the cosine of 45 degrees is radical 2 over 2 times the sine of 30 degrees is 1/2. So really I have radical 2 times radical 3, which is radical 6. 2 times 2 is 4. Minus radical 2 times 1 is radical 2. 2 times 2 is 4. Since they have the same denominator, I can write them together. And I get radical 6 minus radical 2 over 4. And that is the value of the sine of 15 degrees. Done. So that's a sum and difference idea behind sine. And in this case, I did difference because of 45 minus 30. Do look at your formulas for it. Is for the difference for sines, the operation stays the same. Let's look at 13. Now this is tangent of 105 degrees. Well, I want to create 105 degrees. And how am I going to do that? Well, I'm going to do sum or difference. Now, I am going to use 60 degrees plus 45 degrees. If I get to use and choose, and I have the possibility to, I am always going to try and choose in the first quadrant. And the reason why is because all students talk constantly. All of them are positive in that case. And so it's going to make my life easier to work with positive. So if I can use angles that are in the first quadrant, I'm going to. So I can look at my formula, and we have for tangent, for sum and difference, we have tan, tan, 1 tan, tan. And so in this case, I have tangent, tangent, and then a 1 tan, tan. So I have tan, tan, 1 tan, tan. And so I'm going to plug in my angles. I'm going to plug in 60 degrees. And I believe when you're dealing with sum of tangents, on the top, the operation stays the same. So I have a plus there, and I'll put the 45 here. However, on the bottom, the operation changes. So that's going to be a minus sign, and I'll put the 60 degrees here and 45 degrees there. So that is it. And we are so going to need more room than that. So we're going to shrink that down, and let's figure out what we're going to do. So when I have this case, the tangent, I'll just go top first and then the bottom. The tangent of 60 degrees. Start there. The tangent of 60 degrees is the square root of 3. And let's move on to the right. So I have plus the tangent of 45 degrees. Well, that's just 1. Over 1 minus, and I'm going to multiply these two together, which, by the way, are the same numbers as above. The tangent of 60 and the tangent of 45. So really, it's going to be radical 3 times 1. So what do I really have? On top, I have the square root of 3 plus 1, yet on the bottom, I have 1 minus the square root of 3. So if I look at this, what's wrong at this point is I have a denominator that has a radical in it, and we can't have that. I have to rationalize for it. And so if I'm going to rationalize, what I want to do is I want to multiply by the conjugate of the bottom. So I'm going to multiply by 1 plus square root of 3 on the bottom and the top. Clever form of 1 used to rationalize. Notice I'm putting parentheses around it so I can distribute. On the top, if I distribute, radical 3 times 1 is radical 3. Radical 3 times radical 3 cancels out the radical. I'm just left with 3. 1 times 1 is 1. 1 times radical 3 is radical 3. Now on the bottom, remember, these are conjugates of each other. So that, again, is the idea of difference of squared. Is you have a squared minus b squared. So I'm going to square the first term, and I'm going to square the second term. So square root of 3 squared is 3, and you subtract them. So let's see what happens. Radical 3 plus radical 3 is really 2 square root of 3. 3 plus 3 is 4. Sorry, 3 plus 1 is 4. And then 1 minus 3 is a negative 2. I notice here that my coefficients all are even with the bottom. I can divide everything by a negative 2. So in this case, I am going to get a negative square root of 3 minus 2. I believe on my answer key, I like to write the radicals next. So I have it written as negative 2 minus square root of 3. So tangents are more complicated, but I want to let you know the steps to change. Is you're going to always work with conjugates. You're going to have this radical on the bottom, so you're going to have to get used to that. And you've been doing it with sines and cosines every once in a while. Now we're back to the algebra with roots. Let's look at number 14, the last one. Cosine of 270 degrees minus theta, verified equals negative sine of theta. So let's try it out. I want to keep this. By the way, I want theta. So I'm going to keep theta. And this is cosine. It's a difference. So cosine is cosine, cosine, sine, sine. So cosine, cosine, sine, sine. And I'm going to give myself some more room. And for cosine, whatever the operation is, changes for difference. So I have the cosine of 270 and theta, the sine of 270 and theta. All right, so if I were to go through and figure out what I'm going to do is I'm going to look at the trig chart. What's the cosine of 270? And that is 0. So I have 0 times the cosine of theta. And what's interesting about that is, well, multiplied by 0 is just going to cancel that term out. Over here, the sine of 270 is negative 1. So I have negative 1 times the sine of theta, which equals negative sine of theta. Well, that just means negative sine of theta equals negative sine of theta. In a sense, this is asking us to verify that it is an identity, QED. It has been demonstrated. So in this case, notice I want to keep my theta because it's actually in the answer on it. And I'm kind of doing the same thing I did with the difference of sine, just plugging in my angles that are given to me and whatever's in an actual angle measure. I'm trying to find that value using a trig chart, and something's going to cancel based off of what I see on the right side. So that is your entire 5153 review talked through for you on everything. Hope you enjoyed it. Good luck on your quiz.